In traditional 3D animation, artists control a mesh asset using a skeleton system. Recently, advancements in text-to-4D technology have enabled the distillation of neural deformations onto GNU or 3D GIS assets from video diffusion models. Skeleton-based characters provide excellent motion controllability thanks to their low degrees of freedom, but they typically demand extensive manual effort from digital artists. On the other hand, text-to-4D generation leverages internet-scale knowledge, but its high degrees of freedom often results in unrealistic deformations. We introduce IKD, Articulated Kinematics Distillation, to seamlessly blend the strengths of both worlds. We take a 3D GIS asset from text to 3D systems and embed a low-def bone system for motion control. Bone transformations deform the asset, and the rendered video, paired with the text prompt, is fed into a large video diffusion transformer. Video SDS loss then refines the articulated motion to align with the text. Our skeleton system is simulation-ready. We can use physics-based motion tracking to project synthesized motions onto physics-grounded ones. Specifically, the skeleton system can be directly simulated using a rigid body simulator with active joint controls. The simulated sequence is matched to the synthesized motion, ensuring that the tracked motion is physically achievable while retaining the style of the synthesized motion. We compare our method with the state-of-the-art open-source approach, TC4D, that can synthesize long trajectory motions. TC4D frequently produces blurry artifacts, particularly in areas where the legs converge. While the low-def skeleton-based motion control in our method allows the distillation process to focus more on overall articulated motion patterns rather than local-scale shape deformations. Another common issue with TC4D is its tendency to rarely generate alternating leg movements, resulting in unrealistic leg motion. In some cases, TC4D produces highly restrictive leg motions. Here we show physics-based motion tracking results. The floating issue in synthesized motion is resolved by gravity. When viewed from the back, the foot skating issue in the synthesized motion is resolved through frictional contact. Here are more examples. Our method supports the synthesis of different motion modes based on different text prompts. Here we illustrate the differences between walking and running behaviors. When trained without ground rendering, the assets may exhibit severe foot skating issues and appear to float above the ground. When trained without a ground penalty, the results may penetrate the ground. When trained without a smoothness penalty, the asset may experience large, unrealistic deformations. Our text-to-3D module is interchangeable with other alternatives. Here, we extract assets from the static and dynamic phases of TC4D. Our method achieves comparable visual quality while showing a greater magnitude of motion.